Alright, in this video, we are going to be talking about segments of a circle and specifically about tangents and different segment lengths of that. The objective today is we will be able to find the length of a segment when the tangent is involved, and we will be able to determine if a segment is tangent to a circle. So here's our first theorem. In a plane or a flat surface, a line or segment is tangent to a circle if and only if the line or segment is perpendicular to a radius of the circle at its endpoint on the circle. So here we have a line M that will be tangent to the radius QP only if it is perpendicular. So let's see what this means for us. Here is our problem, and PT is a radius. We know it's a radius. It goes from the center of the circle to the outside edge of my circle. And we want to know, is this tangent to the circle? Well, all the problem's really asking is, does the Pythagorean theorem work? That's what this is really asking. Does Pythagorean theorem work? So we're going to take this triangle. Right here at the radius and the tangent would be our right angle. And now we're just going to plug it into the Pythagorean theorem. A squared plus B squared equals C squared. A and B are the sides, and C is our hypotenuse. 35 squared plus 12 squared equal 37 squared. And this is the big question we want to know. Yes or no? So we'll go ahead and we will square 35, which is 1,225, plus 12 squared, 144. And we want to know, does that equal 37 squared? In other words, 1,369. Combine the values on the left, so 1,225 plus 144. So what we find is that each side of this equation comes out to equal 1,369. And that means that yes, this is tangent. If the Pythagorean theorem works, then we are tangent to the circle. So yes, ST is tangent. If those numbers did not come out the same value, then it would not be tangent. We can also use our theorem about tangents to find the length of a radius. So here we know AB is tangent, and we want to find the length of our radius. So we know that this means, does the Pythagorean theorem work, or do we need to use the Pythagorean theorem? So let's go ahead and label the sides of our triangle. Remember, this would be our right angle where the tangent and the radius would meet, which means that R would be A, 80 is B, and then this here would be my hypotenuse. And we're going to talk about that length here in just a second. Let's start this off first. A squared plus B squared equals C squared. And we just said that R is A, so R squared, and B is 80, so 80 squared. Now this other length, 50 and R. Okay. What we want to do is we want to add those together because it's the blue piece there plus the red piece that makes that entire hypotenuse length. So C is 50 plus R, that's the whole length across, and we want to square that quantity. So on the left side we have R squared plus, and then we have 80 squared, 6,400. Now we need to talk about this quantity, 50 plus R squared. When you square a quantity, remember that squaring is just taking it and multiplying it by itself. So it's really this here. And what we want to do is we're going to double distribute. So 50 times 50 is 2,500. 50 times r is just 50r. And then do the same thing for the next term. R times 50, so 50r. And then r times r would be r squared. So this whole thing is going to go over here on the other side of our equal sign. But when I write it over there, I'm going to go ahead and combine these like terms right here. So 2500 plus, and I have 50r and 50r, so that's 100r plus r squared. And now we want to solve for r. So I'm going to go ahead and move the r squared on the left over to the right by subtracting r squared. That way all of the r's are on the same side. 6400 equals 2500 plus 100r. And the r squareds actually cancel out, so we don't have any more squareds. Now it's just linear. So subtract 2500 from each side. $3,900 equals 100r. And then we'll divide each one by 100. And we find 39 equals r. Or to be more precise, 39 feet would be the length of our radius. Now, remember, all we did was we just started with the Pythagorean Theorem, but we had to incorporate a few of our algebra skills. So we had to multiply binomials or square a binomial, and then we just solved for our r. Okay, here's one for you to try. Determine if AB is tangent to the circle. So remember, determine if it's tangent. That means, does the Pythagorean theorem work? So let's just talk about this real quick. Here is my right angle. You want to make sure you're utilizing the length of the radius for your hypotenuse here. So my radius is 6, but that means this piece is also 6. All right, so I gave you guys a good start on how to think about this problem. Go ahead and determine, is this segment AB tangent to my circle? Go ahead, hit pause. All right, so let's just run through this real quickly. So A and B are the sides of my triangle. So 6 squared plus 7 squared. And C is the hypotenuse, but we want the entire length of the hypotenuse. So we want 6 plus 4, that whole length. 6 plus 4 is 10, so we're going to square that. 6 squared is 36, and 7 squared is 49. 10 squared is 100. Add 36 and 49 together, and when we do that, we get 85. So 85 equal 100. This is not a true statement. 85 is not the same as 100, so no, this is not tangent. And again, that's because the Pythagorean theorem doesn't work, which means that we don't have that right angle, so it cannot be perpendicular. All right, we're going to go ahead and look at another theorem. Okay, this is what I call the ice cream cone theorem. So tangent segments from a common external point are congruent. So in the diagram here on the left, okay, we'll come to our ice cream cones here in a minute. If the ST and SR are tangent, that means that they are congruent, okay, because they have that point S in common. I call this the ice cream cone theorem because if you have an ice cream cone, you want both sides to be equal length. That's what keeps your ice cream on top. So that would be our ice cream cone on the left. If we had an ice cream cone like the one on the right, where the sides of my cone are not equal, you can see how your ice cream is going to slide off the edge of that. It won't have anything to sit on. So that's why I like to think of it that way, is when I look at this diagram, if you were to turn that diagram 90 degrees, you could see that the circle would be like your ice cream scoop, and then the tangent segments making that triangle outside kind of becomes like your cone. So here we go on example 3. We're going to solve for x. So again, if I was to rotate this 90 degrees, you could see our ice cream cone, where you have the cone as that triangular part and then the circle being the ice cream, which means that these segments need to be congruent. So RS would need to be congruent to RT. So geometry terms, we use congruent, but algebraically, we would use equal. So RS is 28. That's going to equal RT, 3x plus 4. And I'll subtract 4 from each side. So 24 equals 3x. And divide by 3. X equals 8. And that would be it for that problem. But we can use that theorem for more complex problems such as this. So here we actually have a circle inside of a triangle. And we want to find the perimeter around this triangle. So this diagram actually has 3 ice cream cones. So there's 3 triangles, so there's 3 ice cream cones. One on the bottom left, one on the top, and one on the bottom right. But we need to start off with the ice cream cone that has a length for one of the sides. So here I notice that I have a length of 9. So I'm going to start on the bottom left corner of this triangle. Since this 9 is kind of like that top piece, the other corresponding piece of that cone would also be 9. And now from here, I'm going to go ahead and work to find the other lengths. If I look down here at the bottom, I see the entire length across is 16.5. But I know that left piece is 9. So if the whole thing is 16.5, but the left piece is 9, I can subtract those. 16.5 minus 9 is 7.5. And so that gives me this length here. And now I can finish out that ice cream cone. So on the bottom right ice cream cone now, we're looking at that one. If one side is 7.5, then the other side also is 7.5. And then I'm going to repeat that same process for this top pieces of my segments. So the whole length of this upper left side is 15.1, but I know that that bottom piece is 9. So if the whole thing's 15.1 and part of it's 9, I can find the remaining bit by subtraction. The whole thing minus the piece I know. So this is going to equal 6.1. So now if I'm looking at the tangents on the top, or the ice cream cone on the top, one side is 6.1, then the other side is also 6.1. Now we have found the length of all the different pieces here, and we're just going to take this and add them all up, because that's what perimeter is. Add them all together. 6.1, 6.1, 9, 9, 7.5, 7.5. We add all of those up, and that gives us a perimeter 45.2. All right, now you try. Here's a problem. Find the perimeter of this triangle. Go ahead, try it out. Okay, so this problem here, finding the perimeter, we're going to start off with our 12 and say that the matching side is also 12. At this point, we're going to look at this top left side, and if the whole length is 21.5, I am going to subtract 12 from that, and I find that this other piece here is 9.5. Again, I'm just subtracting 21.5 minus 12 equals 9.5. And so I can carry that 9.5 over to its matching side right here. And now I can repeat that same process, but using the new number of 21.3. So this entire length is 21.3. And I know a part of it is 9.5. That means that this length is 11.8. And so the matching piece must also be 11.8. You add up all of these pieces, so 12 and 12, 9.5, 9.5, 11.8, and 11.8. When you add them all up, you get 66.6. Nice job, guys. All right, so let's just wrap up a little. So remember that tangents are perpendicular to the circle. Okay? That means if I have a tangent segment to a circle, the radius will be perpendicular. And to check for that, we're going to be using the Pythagorean theorem. And don't forget about the ice cream cone theorem. You've got to have congruent sides of the ice cream cone or it's going to slide off. And that's all we have for tangent segments in this video.